Hey guys, it's time for our next exclusive video and it's about HTTP in huge detail. I'm going to explain to you all the different cases and concepts in the HTTP, and while I'm going to cover some of the basics, for example, how requests and responses are constructed, I'm going to explain to you the more advanced topics of the HTTP protocol and what use cases it has behind the scenes of the ASP.NET Core technology. I'm going to also reference each concept to different parts of the ASP.NET Core framework and how it was implemented. This topic is super important because it bridges the gap between the server-side technology and the client-side technology. And a lot of times when people learn how to build client-side apps, for example, with React, with Angular, with Vue, or whatever, and then they decide to become full-stack devs and learn how to use, for example, our technology, ASP.NET Core, they understand parts of the whole, but they don't understand the communication between the two frameworks. And that's problematic because when you want to debug your application, for example, you have a form, you hit the submit button and nothing happens. And to understand what exactly happens and why your code is not working, you can analyze the HTTP request, you can analyze the HTTP response. By using the network tab in the Google Chrome, for example, you can see what's going on with the requests and check whether the client is okay and you need to validate the server side part of your solution, or you may see that, well, the request is not okay, so apparently the problem is in the JavaScript part of my solution. So it's super important to understand everything HTTP offers, because this is how you can easily debug your application and understand the big picture. So this is key and fundamental knowledge. So I suggest for everyone who is not very familiar with HTTP and it's not very familiar with all the concepts behind it, to watch this video. So what is HTTP? Well, we already know that HTTP is, most probably you know that, it's abbreviation of Hypertext Transfer Protocol. It's essentially the client-server protocol for the internet. What does that mean is this means that when a website tries to fetch an external resource from some server, it communicates with that server, and the communication is done through the HTTP protocol. So when we transfer any kind of resource through our browser, usually we use HTTP. And the HTTP is request response based. So we hit something and say, I want to make a request for that particular resource. The server, which is an external computer, a remote computer, receives that request and validates the information of the request and decides to return some sort of a response. The response may vary. It may be you are not authorized to see this resource. It may be you need to provide more data for this resource. It may be here is your resource, thank you. It may be sorry, but the resource was not found, and so on and so on. So the whole HTTP protocol relies on requests, responses, and the so-called URLs. The URLs is just the location of the uh, external resource. You know what a URL is, so I'm not going to cover it in detail. Of course, it's important for a developer to understand different parts of the URL. The developer should understand what is the host, what is the protocol, HTTP or HTTPS, for example. The developer should understand the what is a path of a URL, what is the query string, but I believe most developers who use server-side technologies or who use some front-end frameworks should be familiar with this concept, so I'm not going to explain them. It's the thing about HTTP is that it's stateless. So every request is done like no other requests were created or issued from this client before. So if we have a server here and a client here, a client is usually a browser, but it's not necessary. But most of the time the normal user uses a browser. So the browser makes a request to the server and the server returns some response. That's completely fine, that's okay. The second request to the server is done like the first never existed. So the server doesn't recognize clients and doesn't recognize uh, different requests between clients. Every time we make a request, it's considered like a new request. Of course, there are mechanisms that we can send information to the server so that the server can identify us, but the HTTP as a whole is stateless. Every single request is individual request and the server doesn't make any difference between this one, or this one, no matter whether the client was the same or the client was different. It doesn't matter. So the important part here is that a lot of people don't understand HTTP and a lot of people don't understand the need to understand HTTP because they don't see it. They click on a button, they write some code, they send some requests, but they send the request through abstract APIs. For example, when you're using React or Angular, you just say, fetch me that data. Give me that data and map it to an object. And you don't understand what is happening behind that fetch, what's going on. And if you don't understand what's going on behind the fetch, you won't be able to debug why your fetch is not working. Also, the same thing may happen with a server-side developer. We have model binding, we have actions, controllers, everything is so automatic that we don't see any part of the official HTTP request. And this is how we can develop web applications without understanding HTTP at all. And when for some reason I'm sending a form to the server and the server doesn't understand the form or doesn't bind the form, and I'm wondering, okay, but why it's not working? It should be working. Well, everything is in the HTTP. So anytime you develop a full stack app, or not only full stack app, but most of the time when you develop the full solution, and if something is not working, and if you are not understanding why something is not working, you should go to the Chrome or the browsers developer tools, hit the network tab and analyze the status codes of each request, analyze the request that fails. For example, you fetch some data to /images/ myimage.jpg and it's not working and the image is not there and you start wondering why my image is not there. Open the developer tools, see the network request and see why it's not working. I'm going to show that in a minute. So every time you need to debug something in a web browser, make sure you check the request and the response. It will help you identify whether the issue is in your JavaScript or whether the issue is in your backend app. And that's half of the job done, actually, identifying what is not working, the server or the client. Additionally, by understanding HTTP, you can optimize the ASP.NET Core technology. You can optimize some of the requests. You can leverage different kinds of features that are included in the ASP.NET Core technology. Okay, so what is a request? The request has multiple building blocks. It has a request method. The methods can be get, post, put, delete, and some other not so famous methods, but you should understand the basics. If it's a get request, the form data, the data you sent as a user, goes to the query string. And if it's a post request, the form data goes in the request body. So in a get request, you get to see the in a get request you get to see the result. So if I write cat, I can see that I wrote cat, but I can see that it's part of the query here. So if I delete that and run it again, I will hit the same logic. So the search here is exactly the same because the URL parameter in the query string is the same. I believe most people understand that, but remember this. If somebody asks you what's the difference between get and post, it's not the typical answer that people give. It's not get is for getting data and post is for sending data. Yeah, that's true. That's correct. But the main difference in terms of technology, because I can write a get request to store some data. It's not correct, but I can do it. And I can make a post request to return data. It's not correct, but it's not correct in terms of rules. But you can do it. Nobody is going to give you an exception. The website will still work even though it's making get requests not in the way that was intended to be done. So the difference is not about getting the data or posting the data. The difference is about that the data the user sends in a GET request goes in the query string, like I showed you in the Google search. So that's the difference between the methods, and that's like an interview question. So make sure you remember the difference. It's not about getting data or sending data. It's about where the data is visualized and where the data is. Okay, then we have an URL. I already mentioned that we have different parts. I'm not going to cover that. We have the so-called headers, and the headers are the most important part of the HTTP, because with the headers, the client and the server communicate and understand each other. So having a header and having a request header means something to the server, and having a response header means something to the client. And with the server, if you set a header, you can control how the client will respond. So these headers are important, and if you want to make some optimizations, or if you want to turn different features of HTTP on, everything is done through the headers. Finally, we have the body. The request body basically contains the data that the user sends. So the server-side technology reads these parts and converts them to logic and objects for which we are very familiar with. For example, controllers, actions, and so on. So the URL is separated, and the server-side technology routes to a method in a class in your solution based on the URL. Of course, you already know that. If you know routing, you know that. But the server also parses the headers, parses the body. So, for example, parsing the query string and the body is part of the so-called model binding. So the model binding is not magical, it just parses the request body. And if the request body is in the format that the model binding accepts it, you are good to go. So it's very interesting to understand how different HTTP bodies are bound behind the scenes. So it's a good exercise for you to create a very difficult form. Just create a difficult form with ASP.NET Core views. Create a form, add select box, select drop-downs, add checkboxes, add nested inputs, add a lot of stuff. Add various inputs in a form, then hit send and analyze the request. See how the browser sends that form. And then go to the server-side part of your solution, go to the controller and model bind that. And when you see how you can model bind a specific request body, then you can easily manipulate the forms dynamically. You can dynamically create checkboxes, dynamically create selects, dynamically create forms, and still model bind them, because I see a lot of people struggle with model binding because they don't understand the HTTP part of the model binding. And a lot of people understand model binding in the basic form, but when they need to dynamically change the forms, they start to struggle with their solution. I can create a video about a bonus video about more advanced model binding stuff, for example, checkboxes or select drop-downs. But if you're interested in that, just let me know down below in the comments. With dynamic JavaScript, creating dynamic forms and still being able to model bind everything. Here is a request example. This is how a request looks like. A typical request has the method get, the URL, the protocol, then a lot of headers, which are just key value pairs. We're going to cover the most important headers later in the video. And then we have the body of the request. So this request don't have any information, so the body is empty. It's a GET request to a host called GitHub api.github.com, some other headers, and this is a GET request. So if you need to debug your application, and if you want to understand that, okay, you click a button and nothing happens, and you know that something should happen. You wrote the code, so you expect something to happen, but it's not. How to debug it? First, think whether the issue is on the server or on the client. How to understand that, how to know that. Take a look at the requests. Go to the web page and see the request. Analyze the request. See whether the data was sent. For example, if you just forget, let me show you an example. I'm going to show very small examples because the concepts are more important, but I'm going to create a new forms controller, or let's just create a form here, it doesn't matter. So I'm saying I want input type name, input type text, sorry, input type text, and then I will have input type text. I'm going to say this is the username, this is the password. Then we have some input type submit to submit the form, login or whatever. I'm specifying the method and I'm saying I want to send the data with a post request. Then I start the server. And write down some of the data, of course. Hit the button, and nothing happens. So why nothing happens? I'm doing this and nothing happens, nothing. So I start to think, well, why my logging form is not working? Is it from the form? Is it from the server? Is it from the client side or the server side? So what I need to do is I need to go to the network tab, hit preserve log because I have a redirect, and then write down my data, hit login, and try to find the post request I did. So this is the post request. This is the URL. The form doesn't have an action, so the URL is the same. And let's see what was sent to the backend. And I can see that I have some inputs, network, localhost, and I can see that the form data, analyzing the request, we can see request URL, request method, some response headers, some request headers, and here it is the form data. I can see that the client didn't send the username and the password to the server. It's not here. And if I don't understand HTTP and how everything works, I may decide, okay, let me try to get the data. So I will create object, and I'm going to say user login. I'm going to say good public string username, and then public string password, because that's what I expect at the backend. And I'm going to say, okay, let's try user login model. Let's put that to be HTTP post and return not found for now. I'm going to put a breakpoint. And I'm running the server. I expect everything to work correctly. I write username, password, hit logging. I hit the action because I understand how the routing works. I go to model and I see no. Why it's not working? So of course, if you're familiar with ASP.NET Core, you will know why it's not working. But the whole problem here is that I need to analyze. This is a super simple form, so it's easy to see. But for a more advanced scenario, you will not understand why it's not working. So we need to go to the network tab, preserve the log, hit login. Okay, it stops here. That's completely fine. You can open the localhost request and you can see the form data, and we can see that we are not sending the username and the password. And then I know that there is something wrong with the form. So by knowing how HTTP works, I know that something is wrong with the form. I go here and say, okay, there's the method post, input type text, and I can say, well, I forgot the name attributes, because model binding works by the name attribute. So depending on the name attribute here, the model binding may or may not understand me. So returning here, refreshing, coming to see, I can see that it still has, I need to restart the server, but this is how I see the request. This is how I understand that something was not right with the form. And hitting login now, I will see that the form is now populating the model binding. So I know that something is okay. So currently I'm receiving HTTP error 404. And I'm like, but why? Why I'm receiving 404? And going here, I'm opening the request and I'm saying, okay, let's check whether the URL is correct. The URL is correct. It's not the URL. Then let's check the form data. The form data is correct. It's not the form data. So apparently the client is correct. I need to check the server. And I go to the server and I see, oh, I forgot to implement the action. So every time I debug, I first open the client, then I try to execute the operation. I open the network tab. I see what's going on there. I see the request data, the form data. I see everything to make sure that the client works correctly, and then I go see the backend. And the original way the data is sent is like this. It's like a query string. Username equals something and password equals something else. And we have anti-forgery token here. So basically, ASP.NET Core and the HTTP work with a query string, but the query string is in the body. This is the default behavior of forms. And in order for this to work, and in order for model binding to work, the content type needs to be application xwww form URL encoded. This header here, content type, tells the server extract the data from the body in a query string format. This here, this content type tells that. If we send JSON, we need to change that to application JSON. So every time we send a JSON, the content type is also changed. So this is important to understand. Having a client not working, going to the network tab, seeing what's going on in the request. If you are using a form, is the form data correct? If you are using application JSON, is the JSON correct? So if everything is correct in the request, then the problem is on the server. So let's go to the server. Let's check what's going on with the server. And if it's the server problem, we analyze what's going on in the logic here. So it's connected, but always see the network tab. When something is not working and when you have errors in the JavaScript console, check the network tab and analyze the HTTP thingy. Here is post request JSON example. It's exactly the same. We have a post request, we have the JSON in the body, but the important part here is in order for our server to understand that this is a JSON body, we need to set the content type too. So if you are making an AJAX request manually, you need to understand what kind of data you are sending to the server. If you are sending form data in a query string format, you need to specify the content type too. If you are sending a JSON format, in order for the server to understand you, you need to provide the content type application JSON. That's super important. Here is the form example. I already showed that, so it's nothing new, but apparently the HTTP works the following way. You have a form, you have inputs or drop downs or whatever, select, for example, input type checkbox. Everything that is important is the name attribute. The name attribute is the thing that is sent to the server, and this is how the server understands your request. So when you hit submit here, you will make a post request with content type application form URL encoded, and the name and the age from these inputs will be provided here in the query string format. That's how forms work, and this is how we can debug if a form is not working. Also, if you're not familiar how other model bindings work, just generate input type checkbox, for example, for a Boolean property and see how the browser sends the data, and you will understand how model binding works. This is a great exercise to understand the whole process from the client to your action. The HTTP response has almost the same building blocks. It has a status code. Most of you are absolutely familiar with status codes. You know that status codes with 4 mean client error, codes with 5 mean server error, and so on. 200 OK is a status code representing everything is fine, and so on. So I'm not going to cover the status codes. Again, we have a status code in the URL which returned the response, but again we have headers and body. And the headers tell the client or the browser what kind of body we return. Do we return HTML? Do we return CSS? Do we return whatever, something else? Do we return JSON? So that the browser can analyze the headers, see the body, and decide what to do with it. If it's HTML, it's going to render it. If it's CSS, it's going to apply it on the current HTML, and so on and so on. So the browser and the JavaScript reads this and convert them to logic, objects, visualization, or so on. So again, if something is not showing, for example, we click a button and something should show on the client. What should we do? We click the button and nothing happens. Okay, the first problem may be in the button itself. So we go to the network tab and see whether the request is sent. Then we see the date of the request. Is the date of the request correct? Yep, okay, good. Then check the server, whether does the server return a correct response? Yep, the server is okay, so apparently it's not the server. So go to the network tab and see the response, see what is returned from the server. And then you may realize that you're returning something from the server that's not correctly applied from the JavaScript. So by going the whole way from the client to the network tab and the request, to the server, back to the network tab and the response, and finally to the client, you will understand where exactly is the problem, what is not working. And if we go somewhere, for example, let's make this request and let's see what's going on. I'm going to remove the preserve walk, and we can see that the browser made a request to localhost because that was the original URL. Call this URL. And we can see that the response headers are, well, the content type is text HTML. Get the body of the response and visualize it as HTML. And if we go to the response, we can see that it's a normal HTML. It's the HTML which is visualized here. Then the HTML has a link to some CSS, another link to some CSS, then it may have a link to a JavaScript file, another JavaScript file. Each of these fires a separate request. So the bootstrap means CSS. If we check it, we will see that the server returned content type text CSS, which apparently means browser, please use this CSS file to apply some styles on the HTML. Then with the second CSS it was the same. Then with the JavaScript file we can see that the content type is application JavaScript, so the response is triggered as a JavaScript code. And this is how the server and the browser communicate. Every single request returns some content type, some information of the response, and so on. So, for example, let's say that we have a wrong URL. And let's restart the server. Of course, these examples are way simple, because a lot more simple than usual, but something is not working. Okay, apparently the CSS is not firing. How to debug that? We go to the network tab, we refresh everything and analyze the requests. Request 304 means the browser cached the file and it's no longer It's not requested from the server, but it means everything is fine. But we can see that we are requesting some bootstrap min CSS. So check the URL. Why it's 404? First reason, the URL is not valid. Second reason, the file is not there. So I go to the server and check what's going on. I'm going to lib bootstrap dist css bootstrap min css. I check the URL and see that I have a typo here. So what I need to do is I need to go and fix it. But I'm debugging not by guessing, I'm debugging by analyzing the HTTP, analyzing what's going on here. And you can do this concept and this debugging mindset with every single web application. Client, request in the network tab, server, response in the network tab, client, and you will see what fails and why your code is not working. Example, response, I already showed you one on Google Chrome, but again, the protocol, the status code, some headers, and the body. This is how a request looks, a response looks like. Good. Let's talk about the headers and all the concepts we're going to cover. So the HTTP headers allow you to manipulate the how the browser and how the server react. So you can control the communication with the headers. So the headers are essentially the data that the user doesn't see. The headers are just part of the machine-machine communication. Of course, some headers are not supported by all browsers or by all servers, but that doesn't matter. Normal technologies here, for example, all the latest browsers or the ASP.NET Core technologies, all of these understand the standard headers I'm going to show you, and I'm going to show you each of these standard headers where it's implemented in the ASP.NET Core framework. So, as a developer, you can look at the headers to understand why a request or response is not working correctly, especially if you are writing a more lower level server, because you can go and you can create app use, and you can say something like next goes to let me check we have the HTTP context and the task. It should be something like context next, and then let me stop that because the green lines make me nervous. Okay, so I can make something like if context dot request dot query dot contains key secret we have a cat here. Hey cutie, what you doing? You don't understand English, you know. Understand Bulgarian only. Bulgarian, typical Bulgarian street cat. She loves to cuddle. So, okay, we have a context. This is the HTTP context. We have we have a request and response object here, and we can write a low-level server. We can say something like, if the query doesn't contain a secret, sorry, I'm not going to continue with the next execution. I'm not going to check for static files. I'm not going to check for routing, authorization, the MVC pipeline, and so on. So, what I can do here is I can say this dot context dot response dot status code equals 404, something like that. We can say context dot response dot write async, sorry, something like that. And you can say async await, await, and that's it. So we wrote a low-level server working with HTTP directly. We have the option to work with headers, we have everything here. So we essentially said if the request doesn't contain the secret, sorry, but return 404. So opening that page, and I'm receiving sorry because that was the first thing that happened on this page. So that's apparently a problem. But if I add a query string secret equals some value, everything starts working correctly again. So it's by adding and controlling headers, and if you don't want to use the MVC pipeline because it adds overhead, if you want to have some very small server, you need to understand the HTTP and how to control it. Okay, so what are the capabilities of the HTTP headers? These are all the topics I'm going to cover in a minute. We have access control, authentication, caching, conditional requests, compression, content negotiation, range requests, redirects, and cookies. I suggest, because I'm going to explain the different headers of each of these concepts, but what you can do is you can try as an exercise to play with the headers. You can go to the index page and you can say something like this response dot headers dot, or just get typed headers because it's easier to understand. Give me the headers, and then you can say headers dot cache control equals new cache control header value, and then you can say something like public true and try to see what will happen. So play with different headers. I'm going to explain the headers now, and then you can play with them. You can try different things, and you will see how the server responds, how the client responds, how the server responds. For example, let's add that to the privacy, and I'm going to add my max age times span from days 1, for example. So the privacy page will now have a cache control header with a public attribute true. Public attribute true means that the browser can cache the data. I'm going to explain it in a minute. So hitting privacy here, we hit everything. Then I'm hitting privacy, opening that, and I can see that the browser is now caching the response. Here it is from disk cache. I can see that the response is cached, and I can check that by adding a thumbnail here and hitting home, then privacy, and not thumbnail, breakpoint. Hitting the breakpoint is not hit, and it's not the problem in Visual Studio or in the server, but the problem is that I added a header on the privacy URL, and I returned a cache control public header, so the browser is now caching the response. So it's not calling the same URL again. Of course, if I disable the cache from here and hit privacy, it will start working again. It will hit the server again because the cache is disabled. And also if I hit Control plus F5, I will refresh everything. So try to understand all these concepts and try to the exercise for this video to understand how everything works together. First is to try to work with model binding and find some interesting things with model binding. For example, if the user login has a checkbox, just experiment, just try with different stuff around the model binder. So I'm going to say some checkbox. Then in the index page, I'm going to say I have a model, which is user login, and I'm going to say input ASP4 equals some checkbox, ASP4 equals some username, and ASP4 equals some password. And then what I can do is I can go to the quant and I can see what's going on. So this is a great exercise for you to try different things with the model binder and see what's going on. See how the model binder works. If we analyze the HTML, we can see that there's an input type checkbox here. And if, for example, I click the checkbox and hit login, I can see the form data that was sent. And I can see that the form data actually sent a very interesting thing. I can see that the form data sent username something, password something, and some checkbox true, but there is some checkbox false also. So the model binder receives two checkboxes. That's strange because I created only one. Here it is, some checkbox true, some checkbox false. And where is the second checkbox then? We can see that I have another checkbox which is hidden. So in order for the model binder to work, the ASP.NET Core creates two input type checkbox. One is hidden behind the scenes. And if you don't play with the model binder like I told you, you won't understand how the checkbox work. That if you want to dynamically add checkboxes to a form, you need to do it by adding two checkboxes, one with the false and one with the true. And if we disable this and hit login again and go to the form, we will see that this time only the second checkbox is sent. That's because the first checkbox is not selected, and this checkbox is always selected. There are small little details which will help you understand how model binding works, how everything works. So that's the first exercise, play with the model binding. The second exercise is play with the headers like I showed you. I added a header on the privacy action and the browser started caching it. So I'm going to explain all the different concepts here. The first is the access control. The access control is the plain old course. Access control is adding a header specifying which domains or headers or methods have the access to this resource. So a browser makes a request, the server returns a header having the following name: access control allow origin. And in the allow origin it says cats.com, but I'm making the request from docs.com. And because of that header here, which allows only the cats.com request, the browser returns an error. So we can give access control to our API or our server by adding these headers. I can specify, okay, I'm not allowing anything else but get methods. So anyone trying to make a post request here will receive an error. Also, we can restrict the access of our web page to our domain. And this is how the browser will restrict the access here. This is to prevent different and various fishy websites accessing the data. If we don't add the access control, everyone can access the data. So, for example, access control allow origin. This means allow everyone. Everyone is allowed to access this resource. Access control allow origin coded up.today. This means that only this website can access the resources. Only requests from this website can access the resources. How to use that in an ASP.NET Core technology? You use the course middleware. You just say use course, going to the startup. If you say app.useCourse, and you can specify the course here. You can specify allow any origin. This will add the header to the request. So this is how this technology, this concept works. Adding course just adds the header, and then the browser knows which domains can access the resource. The next thing is authentication. Authentication, I'm not going to cover a lot about authentication, because authentication in general is a huge topic. I can talk 4 hours about authentication, but authentication can be done through headers. So there is authorization header. I guess everyone watching this video who worked with JWT tokens understand this header and know that somehow the server understands the authorization header, understands the token, and then returns an authorized result. But the usual workflow is client makes a request, the server returns 401 unauthorized by adding sorry, you are not authorized by the status code. Then the user logs in, and then the user has a token which can be put here, and we add an authorization header saying bearer with the token, and then we have a status code OK or a status code forbidden. This is how it works. But authentication and authorization in the web happens with the authorization header. Caching. To use caching, you use the cache control header. Exactly what I did 5 minutes ago in the code. I added the cache control header. Keep in mind that I added the cache control header with a strongly typed header because I have compilation, I have IntelliSense and so on, but I can easily do something like this: response headers add, and I can say add cache control and make it public like this. So I cannot do it with C#, I can do it with strings directly. The strings which represent the specific header name from the HTTP specification. But of course, it's easier to work with strongly typed classes, so I prefer this way. Even though it's a little bit more longer in terms of code lines, it doesn't matter, it's easier to see what's going on. So the cache control has multiple values, but the most typical ones are public or private. Public cache, it means that this data is shared, so the browser can cache it and show it to everyone without requesting it again. Private cache means that this data is for the current user, for the current session only. So for the current user, don't fetch the same resource if he makes the same request, but for another user, for another session, then fetch the resource because it's only for this user. And you can add max h, which means how many seconds the cache will live, and then it must be the resource is no longer in the cache. We can also add must revalidate, which means that every time the browser has something in the cache, it will revalidate whether the data inside is still valid or it should be requested again. I'm going to show that in a minute. The cache will be revalidated only if the user presses the reload button or hits Ctrl plus F5. How to revalidate a cache? Revalidating is done by one of the two headers, etag or last modified. So the etag is a unique identifier which is something like A5C1D7, some random string. The server recognizes this string and the browser has an etag. So the browser sends the etag, and if the server has the same etag, the server returns that the data is not modified, so the browser can use it from the cache. This is how we can protect the browser from fetching multiple images, multiple times the same image. We can add an etag. And then if we want to change the image, we can change the image with another etag, and then the client will send this older etag. The server will see that this etag is no longer valid, and it will return the whole image to the browser. So the browser can validate and make conditional requests. We're going to see them in a minute. So the browser can make a request and say, I want this picture. Is it the same as the one I have in my cache? And if the server says, yep, it's not modified, the server doesn't return the image to the browser, and the browser renders the image from its cache. Again, it's the last modified is just another technique because the data is just checked against the date. So if the server has a newer version of that resource, it will return it. These are two concepts of revalidating a cache. We can add the vary header, which can be added to distinguish different responses from the same resource. We can say if there is a different user agent, return a new value and not use it from the cache. Or you can say vary by header, by content type, by different types, by encoding and so on. So we can control when the cache will happen and when not. In the ASP.NET Core technology, the response cache middleware and action filters help with these headers. So instead of adding headers here, I can easily say response cache, and I can add some caching here. I can say, for example, duration equals 60 seconds, something like that. We can see that this sets max age in cache control header. I can say something like no store, or I want to say cache profile response cache location. Location equals client, for example, and this makes the client to cache the data, and so on. So we can use the response cache middleware to send headers without writing the headers themselves. Of course, if we want more complete control based on some logic, we can use the headers directly. But for common scenarios, you can use the response cache attribute or the response cache use response caching middleware options, goes to option, and you can specify the response cache with various different. Oh, sorry, you cannot. That's not the way it works. You just use response caching, and then use the attributes and the filters here and there. This is how we can do it, and you can say services at response caching, and here we have options. Sorry, we have options on the service level and not the middleware level, but you can add different options. For example, size limit, maximum body size. You can do use case sensitive paths. You can add different response caching. Also, you can add policies of the response caching. You can do different and various things, but you should read in the documentation how it's done. But the response cache middleware and the action filter essentially use the cache control header with the it tag, with the last modified, and you can even add more control by using these headers. Conditional requests. Conditional requests are part of the cache control because these requests are based on the headers. The headers define some precondition, and the server result will be based on whether the precondition was matched or not. For example, if the server sends an e tag, then the client can send and can say, if the e tag matches this e tag I have here, then return me the new data. And if the e tag doesn't match anything, then return me new data. So I can control the request by adding these headers. For example, I can add if modified since. So I can say, hey server, give me the file only if it's modified since, for example, July the 12th, for example. And the browser then receives not modified status code if the resource was not modified, and a 200 OK status code if the result was modified. So these requests allow us to create conditional headers. In the ASP.NET Core framework, we can see that these requests and these headers are done in the static files middleware. I'm going to show it now. Going to the static files, use static files middleware if, for example, the CSS is changed. Some class, color red. Then if I go to the browser and run the app, we can go to the network tab, we can refresh, and we can see that the server gave us a file. That's not the file, it should be site CSS. The site CSS file, the server gave us an e tag and the last modified. It said it was last modified at this date. Then when the server requests again the site CSS file, the server returns not modified because the client sends if modified since and if none match. But as we can see, nothing was modified, so the server doesn't return the whole CSS, it just returns not modified. And if we modified the file, the client will send, hey, check if modified since, and the server will say, yeah, I have a new version, here you are. So this is how conditional requests are done. Give me the file only if you have a different e tag, or only if you have a newer version in terms of dates. And the static files implement that. Of course, you can implement the same logic in your actions if you think that it's valid. Let's talk about compression then. Compression is used to save some data. It's used to save some information. You can save some traffic. From there you save network bandwidth. From there you save server resources. It's good idea to use compression of some sort. So you have different kinds of compression. First, you can compress the files. For example, PNGs, which compress the files without losing any quality. But you can compress the files by losing some quality, for example JPEGs. So it varies, but you can compress the files. Then you can compress the whole content by different compression algorithms, for example gzip. And you can use the accept encoding and content encoding to compress or not compress the content. So if the browser sends accept encoding, it will say what kind of algorithm it supports. And for example, the browser may say, I support gzip. So the server may return the response by specifying content encoding of this response is gzip. To enable gzip in your application, let's check the default behavior. The default behavior on local hosts, we can see that we have content type and nothing else. We don't have, the browser said I accept encoding gzip, but we don't provide content encoding. And we can go to the server and we can say something like app use response compression, like this. Of course, we can specify different providers of the compression. We can specify add response compression. We can give some options. For example, enable for HTTPS only. We can provide different algorithms. We can say which MIME types, content types to compress. For example, I can say compress only HTML, CSS, and JavaScript. Exclude everything else, and so on. I can configure that. I can specify what kind of compression to use. Of course, again, it's a good idea to see how ASP.NET Core implements that. If we go here, and hit bootstrap min CSS, we will see that now the content encoding is an algorithm called BR, because the browser said I accept BR. I'm not sure which algorithm is this one, but because usually I use gzip, but nevertheless this is the default behavior. And we can see that everything is encoded by default. Content encoding, everything should be encoded except some images, for example. Good. If we, and the HTML is not encoded because the HTML is part of the view rendering engine. So this is why it's not encoded currently, but you can add it too. If we want to turn on gzip, we can go and say ASP.NET Core, content compression. But the whole response compression happens, yeah, this broadly. That's the name. I learned something today. The broadly compressed data format. I'm going to check later what is, how it compresses and why it's the default. But apparently it's the default and we can change it to gzip, for example. Middleware supported. So we can add gzip. Good. But everything happens through the HTTP headers. That's the whole idea. When you add the response compression, everything happens through the HTTP header. Well, I guess that's quite a long read. so I'm going to leave it for later. Content negotiation is something that happens with the accept and content type attributes. The accept header defines what the client understands. For example, the client may say, I understand text HTML or XML. I understand images. And if the server returns HTML, the browser will understand it. The browser may say, I accept application JSON. Then the server needs to check the accept part of the request and then needs to provide application JSON. So content negotiation is what the client accepts, and based on the content type, then the server returns some kind of content that the browser understands. The whole model binding mechanism works this way. If you say content type application JSON in the client, the model binding understands that and reads the body as JSON. If you say form URL encoded, the model binder uses content negotiation to parse the data as a form. You can do the same as an XML by providing XML here, and the model binder will understand XML, and so on. So you can negotiate the content by using the accept and the content type headers. There is another header which is content disposition. By adding content disposition header, you're forcing the browser to either visualize a file or download it. If you add content disposition attachment header, the browser will not try to render the result, but it will download it. It will send it as a download. So you can control whether a PDF, for example, is going to be rendered, or a PDF, for example, will going to be downloaded by adding this header. You can also specify the file name. On this link, you can find all media types, standard media types. And for example, if you need PDF, you will find that it's application/PDF. Range requests. Range requests allow bigger resources to be transferred in chunks. For example, lengthy videos, because you don't want to fetch the whole video, you want to start playing the video as soon as possible, and you are not sure whether the user is going to watch the whole video, so you don't want to send the client the whole video. That's a lot of bandwidth. So you can use range requests. Range requests are very easy to do, and the ASP.NET Core has a first-class support for them. A range request means that the server needs to return a response saying accept ranges bytes. If it returns an accept ranges header, the client then can try to get chunks by using the range header. So the client then can use the range header by specifying give me only the first 1000 bytes. Then another request, give me the second 1000 bytes, and so on and so on. This way, for lengthy videos, you can fetch only the data that is needed. And that's a better approach, otherwise you will have a lot of bandwidth. The ASP.NET Core support partial uploads and partial requests by using the file result. This should be partial requests. If you say return file, you can specify that this is a range request. You can specify that you will return the file in a range. It's super easy. Just look at the documentation, but it's super fast to do, and you will turn on returning files by ranges. Redirects. Redirects in HTTP are two kinds. You have a permanent redirect and a temporary redirect. The permanent redirect is when the browser never actually tries to access the original site again. So for example, you moved your site from animals.com to cats.com. And if somebody hits animals.com and sees a permanent redirect, the browser will never access animals.com, it will always access cats.com from now on. And the temporary redirect means that the browser will try to access the original site every single time. The redirects are based on the status codes, so if you return a status code starting with 3, for example, 301 moved or 302 found, these are status codes which represent redirects. And when a browser sees a redirect status code, the browser searches for a location header. The location header specifies where the redirect should go. And all the redirect results in the ASP.NET Core support this concept. For example, if I go to the index page and say return redirect to action, the name of this privacy, like this, and if I run that, we'll see that the redirect is happening because of the headers. It's not calling the method, it's just returning a header. And if we go here, if we clear everything and hit home, we can see that the localhost returned a 302 status code. This status code is telling the browser, hey, redirect. And the browser then searches for the location header. It finds the location header, sees that the URL is /home/privacy, and redirects to /home/privacy. This is how redirects work. But since it's a temporary redirect, the browser will always try to load the localhost first. If I go to the code and specify that it is permanent, I can add it somehow, but I'm not sure what was the name. Yeah, redirect to action permanent. Then it means never try to hit the index page again. That's the whole idea here. So based on the status code and the location header, the browser understands that it needs to do a redirect. And this is how you can redirect easily. Just return a status code and a location header. Then we have cookies. Cookies have multiple use cases and most developers are familiar with cookies. With cookies, you can do session management, you can do personalization, you can do tracking. For example, Google Analytics and Google AdWords have tracking cookies. You can personalize the website. For example, if you choose a black version of the website, this may be stored in a cookie. When you log as a user, there may be a cookie to store the session. Cookies are the way to add some state to the stateless HTTP, because by default the server won't understand that you are making a second request. But if the server returns a cookie and if you send the cookie back to the server may parse the cookie and understand that you are the same person. So there's a lot of things I can talk about cookies, but they are mostly related to authentication. But the whole idea is done through the headers again. If a response returns a set cookie header, then the browser will start sending that cookie every time, every single request from now on. And the server may try to do something. Let's do it really fast and we are almost done. It's important to know that each cookie is set for a specific domain. So if a cookie is set, it will be sent only for the domain it was specified for. You can use the HTTP context object and add cookies if you want. For example, let's make the following. Return this view and I can say something like public iAction result, give me cookie. Then I can say something like this HTTP this response dot cookies dot append. I want another cookie. I want to add a cookie with my cookie key and my secret cookie value. And then I'm going to return redirect to action index like this. Then on the index page, I'm going to say if this request cookies contains key my cookie, return view. Otherwise, return unauthorized. So in order for my website to work, I need to have a cookie with the my cookie key. I can even add additional settings for the cookie here. I can add additional settings, for example, what is the domain, what is the time span, the max age of the cookie, when the cookie should be deleted, whether it's only for HTTP, whether it's for only HTTPS, and various other options, for example, a specific path of a domain, and so on and so on. So I can specify different configurations, but that's not that important. If we want specific cookie details, we'll take a look at the options. And let's see what happens in terms of HTTP. So I'm going to the website and I can see that I have unauthorized result here. I'm going to open the application cookies. I'm going to delete everything here so that we can see what will happen, but reloading the site gives me unauthorized, sorry. So I cannot see the site. Then I go to home, give me, what was the name of the action? Give me cookie, give me cookie. I hit that and give me cookie like this. I hit that and let's see what will happen. First, I have a new cookie here. I have some ASP.NET cookie, which was added here for the anti-forgery token, but I have a cookie which is my cookie with my secret cookie, the cookie I created manually. How it was done? Well, the give me cookie returned a set cookie header in the response. Here it is. The response said set cookie, my secret cookie value, and the path was home. So the browser stored that cookie because it saw the header here and stored that cookie in the cookies, and then when it made the second request to the local host, the request header set request accept. Here it is. It set the cookie because the cookie is stored in the browser, and the request said, hey man, here's a cookie. You gave that cookie for me, gave it the last time I asked for a request, so here it is again for you. And the server sees the cookie, checks the logic, and authorizes me. So we can do different kinds of cookie-based uh, cookie-based mechanisms, which allows us to store data. You can also use localhost, but cookies are the difference between localhost, local storage, and cookies is that cookies are always stored and on the browser and are always sent on each request. So if you set a cookie, each next request will receive that cookie, which may be unnecessary. So if you don't want to send the data every single request, it's better to store it in the local storage and send it only when it's necessary. But if you see if you want to send the cookie every time, send some data every time, then the cookie is your option. I should rename my YouTube channel to Programming with Cats. I believe it will be a hit. Everybody will watch it. Programming with Cats. It's a good name, but not a good business idea, I guess. So what are some other interesting headers that you can check? First, the referrer. The referrer contains the address of the page making the web request. So when a browser makes a request, it adds a referrer from which page the request was done. So this can be very useful for storing history, for example. Who called what page? We have forwarded. Forwarded contains information from a proxy server that may be altered by the proxy. So everything that when we have a proxy server, we have a client which is calling some proxy, which is calling some server. So between this HTTP request and this HTTP request, there may be some differences. So the proxy server may send additional headers, for example, forwarded, to provide the information from the original client. And with X forwarded for, this header is for identifying the original IP address, because otherwise the IP address of the request will be of the proxy, and if we want to store the original IP address, we can use the X forwarded for header. So there are a couple of forwarded headers which allows us to work with proxies, so that the proxies will transfer the data that the server may need. And finally, a famous header is the user agent, which is just a string that lets server and the network identify who makes the request. What is the operational system? What is the browser? Everything related. Good, guys. I explained all HTTP concepts. These are the main HTTP concepts. I explained what headers are used in these concepts, and I explained how ASP.NET Core uses the HTTP to leverage these concepts. So, as an exercise, what you can do is you can play with the model binder to see what works with the model binder and what not, to understand what parts of the model binder and what parts of the requests are working together, how the request is matched to a model binder. Hey cat, don't scratch me, because I'm not going to name the channel Programming with Cats, it will be with dogs. Period. And the other exercise is to try to add different headers to some actions. Add headers and see how you can control the browser's behavior. For example, the typed header. These are the exercises you can do to understand better how HTTP works. And the most important part, how to debug. How to debug. Debugging should be done like this. You enter something on a web page, you hit a button, nothing happens, but you think that the button should work. Open the network tab and see the client, see the request. Is the request looking correct? Do you send the correct data, the headers? Is everything looking fine? Is the URL fine? If everything is fine, then the client is great. There is nothing wrong with the client. Go to the server. Check the server logic. If you don't find anything, go to the response and see the response. You may see that you are returning something that the client is not manipulating correctly. And with using the network tab, it will be very easier for you to debug web applications. Good, guys, if you have any questions, leave them down below in the comments, and I'm going to finish now the video. Thank you for watching and thank you for being with me. Bye.